Hey, welcome to one of the most important lectures of the year, significant digits. They're going to be with us all year long, so definitely a good video to follow. Hopefully earlier we watched the video on precision and accuracy. So remember, precision is a measure of how reproducible a measurement is. So we have three examples here. We're measuring the width of this door. We have a ruler that only has a marking at 1 meter, so we're going to have to guess 0.8 meters. We have a ruler that is a little bit more precise and has every 10 centimeters listed, so we can get a little more precise with our answer, 0.77 meters. And then finally we have a much better precision ruler where we have every single centimeter listed. And we can put down at the bottom here 0.772 meters. We can get a lot more precise value with a more precise ruler. Ruler that has more tick marks on it. And that's where the importance of significant digits come in. So significant digits tell us how precise our instruments are. And that can be really important. If we're not using a very precise instrument, we can't record very precise data. We can't let everybody know, hey, it was exactly this much water that I poured in. If I'm not using a very precise tool, I don't know that, and I can't claim that. So, with significant digits, whenever you're measuring something, the rule is you get to measure to the place you have. So we're looking at this first ruler here. We know that the first place is 0. It's not yet to 1 meter. 1 meter would be here on the side. The door is not that long. So we know it's a 0. We're always allowed to guess. In fact, we have to guess one more digit. In this case, we're guessing 0.8. For our second ruler here, again, we know for a fact it's between 70 and 80. So that 0.7, that first 7, that is a known number. The second 7 is our guessed digit. And with the more precise ruler down here at the bottom, we know it is 0.77. We can count 1, 2, 3, 4, 5, 6, 7. We know it's 77. And we're going ahead and guessing one more digit, 0.772. So significant digits show us how reliable our materials are. All right, here we are, reading a graduated cylinder. Remember, always put your eye level, so it might mean you have to bend over a little bit, but always put your eye level to the bottom of the meniscus. That's what we read. We don't read the top of the meniscus, we read the bottom. We follow it over. Okay, we know for a fact it's 30, there's 35, 36. We know for a fact it's between 36 and 37. So 36 is our known digit. We're going to go ahead and guess one more. I think it's about halfway, so I say 36.5. If you said 36.6 milliliters or 36.7, that's fine. I'm not going to argue with your guessed digit. Just make sure you go out to enough digits. Same thing. 30, 31, 32. We think this one's exactly on the line for 32. We don't just write 32. We say, hey, I know it's 32. I'm guessing it's exactly 32, and the way that we do that is by putting a 0, 32.0. I know it's 32 milliliters. I'm guessing it's 0.0. That 0 is the estimated digit. Okay, so understanding what significant digits are. First of all non-zero digits are significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, they're all significant. So 24.7, 0.743, and 714 all have 3 significant digits. 1, 2, 3, 1, 2, 3, 1, 2, 3. Anything that's not a 0 are significant. Any sandwiched 0, these are zeros that are between non-zero digits, are significant. So here are a couple of sandwiched zeros. Guess what? They're significant. Here is a sandwiched 0. See how it's between the 4 and the 2? It's significant. Another sandwiched 0 between 5 and 3. All 3 of these values have 4 total significant digits. Leading zeros. So these are the zeros that are on the left of your number. They are never significant. Now, keep in mind I'm saying they're leading zeros on the left of the number. Guys, do not think about the decimal point. Decimal point does not come into play. It's leading zeros to the left of the number. Here are 3 leading zeros. Don't care about that decimal point. They lead the first number. They are not significant. Here is a leading 0. Again, the decimal point does not matter. It's leading. It comes before the number. Not significant. Again, here's a whole bunch of leading zeros. They lead the number. They're before the number. None of them is significant. All of these numbers only have 2 significant digits. None of the zeros are significant. All right, comes to trailing zeros. So here's an image where we have leading zeros in red and trailing zeros on the end. Here's the rule with trailing zeros. Sometimes they're important, sometimes they're not. Sometimes they're significant, sometimes they're not. It all depends on if there is a decimal. Okay, so on the last rule, I said don't worry about the decimal. Leading zeros never, ever count. Decimal or not, they don't count. Trailing zeros count when there is a decimal. So here's a 0. There is a decimal. 0 is trailing. It is significant. Here are 2 trailing zeros. Guess what? No decimal, not significant. Another example here. Here's a trailing 0. We double check. Is there a decimal? There is. Significant. So again, here's some more examples. 43.00. They're trailing zeros. They trail the number. There is a decimal. Significant. 1.010. Well, this first one here is a sandwich 0, so definitely significant. This one is a trailing 0. There is a decimal. Significant. I'll skip over here to 1,000. Look at the decimal. These are trailing zeros. They trail the number. There is a decimal. They are significant. As an example, 300 meters, that's just 1 significant digit. There are zeros there, but no decimal, not significant. So again, some examples of numbers that have trailing zeros that are not significant. All right, significant digits really only work when you're making a measurement. So how long something is, how much time does something take, how much mass does something have. If you're making a count, for example, how many people in the classroom, 23 people in the classroom, a count is not a measurement. These are exact numbers. So this is not significant. We could say there's infinity significant digits here. That is a count. It is not a measurement, so these are exact. Also, when we make conversions. So I think everyone is aware there's 60 minutes in an hour, 100 centimeters in a meter. Those are exact values. So those significant digits are infinite. Little practice with rounding. Quick rule, hopefully we're all aware with it. So let's say you determine you only need 4 significant digits. Well, you're going to go ahead and round anything from 0 to 4, just round it off. Anything from 5 up to 9, you'll round up. So, for example, this first problem here, 314.721 meters, we're asked to round it to 4 significant digits. All right, well, the 3, that's our first one. The 1, there's our second digit. The 4, there's our third digit. And the 7 would be our fourth digit. After the 7, we have a 2. That is between 0 and 4, so we're just going to round it off. Correct answer with 4 significant digits, 314.7 meters. 0.001775 meters. We're supposed to round to 2 significant digits. All right, well, we've got some zeros here. They're leading zeros. Leading zeros never count. So they don't count. Our first significant digit here is the 1, followed by the 7, followed by the 7. We only want 2 digits, so we're going to stop here at the 7. We look at the number after it. It's between 5 and 9, so we're going to round up. We're going to say 0.008 Or we know how to write it in scientific notation now, so you could write that as 1.8 times 10 to the negative third meters. 8, 7, 9. Well, 8's our first significant digit, 7's our second. 9 has us round up, so 8,800 meters. Trailing zeros count if there is a decimal. Leading zeros never count. This one has 4 significant digits. This one, no zeros, so every number counts, 4 significant digits. And we've got some leading zeros. Again, don't worry about the decimal. They lead the number. They don't count. Here we have some sandwiched zeros. Sandwiched zeros do count. They're between the 4 and the 7. That's 5, 1, 2, 3, 4, 5 total significant digits. Making sure we're getting some rounding in. If we're asked to round this one to 3 significant digits, 8.70, the 0 is our last significant digit. 7 tells us to round up. 8.71 times 10 to the first meters. 4.36, 2 has us round down. And finally, 1.55 times 10 to the second, negative second, excuse me. Again, we could have kept it at 0.0155, that's absolutely fine, or scientific notation. Either is perfectly all right. So performing some operations, 9.44 minus 2.11, 7.33. 1.36 plus 10.17, 11.53. And then this one, we'll discuss this in the next slide. I don't think we're quite to operations yet. So we'll see you on the next video.